Let's look at problem 5 first. So here we have 1.0225 to the power 4 times t equals 2.55. So this is an exponential equation. So this is the variable is in the exponent. So to be able to find it, we will rewrite this equation. We will change it to logarithmic form. So we can say logarithm in base 1.0225 of the number 2.55 equals the exponent, which is 4 times t. So by rewriting it in the logarithmic form, we were able to isolate the exponential. So we are looking for t, so we will need to divide both sides by t. But let's first find the value of this expression, this log expression. So we can change to natural or common logarithms by the change of base formula. So here I use ln, the natural logarithm. And now we can just plug in these values, ln 2.55 divided by ln 1.0225. So when you plug them into the calculator, you will find that the left side equals 42.0705. So the decimal expansion continues, but the problem asks us to approximate up to to the nearest hundredth. So you need to keep more than 2 digits to be able to find the correct approximation, because this is not the final answer, because you are going to be dividing it by 4, so you need to keep more than 2 digits. And then to find t, we will divide both sides by 4, so you will get 10.5176 or something, and you don't need these 2 digits, so you just need 2 digits. This is the answer, rounded to the nearest hundredth. In problem 6, we have an exponential equation because the variable is in the exponent. So this is a type of an exponential equation. But realize that, so this is the exponential expression, and it is multiplied by some number. So there's a coefficient in front of the exponential expression. So to be able to solve it, we will first need to isolate this exponential equation. Okay, so to do that, we will divide both sides by 5, so that we get 10 over 5, 2 on the right, and we don't have this 5 anymore on the left. So we have now a simple exponential expression where 2 to the power 2x plus 3 equals, 4 to the power 2x plus 3 equals 2. So to find x, we can just change this expression, rewrite it in logarithmic form. So logarithm in base 4 of 2 equals 2x plus 3, which is the exponent. Now the rest is to evaluate the value of this expression, and we will also need to isolate x from this equation. So the left side can be rewritten using the change of base formula as ln 2 over ln 4. And I will just do the evaluation, plugging it into the calculator step. I will leave it to the end. So to find x, we will subtract 3 from both sides. So we have 2x on the right. And we need to find x, we need to divide both sides by 2. So just multiply the left side by 1 over 2. So in fact, we multiply both sides by 1 over 2, or equivalently, we divide both sides by 2. So we just found an expression for x. The rest is to evaluate this expression. So here we solved x, and we are asked to find an approximate value, so we plug this expression into the calculator to find that x equals negative 1.25. So in these two problems, we followed different orders. both are correct. You can either take the expression, take the log expression until the last step and evaluate its value, or you can just evaluate a value in the middle and solve for, so just take that value to find the value for the variable.